9-7 notes, we're factoring special cases. In 9-4, we multiplied special cases, these perfect square trinomials and difference of squares. So before we were going from here to here, right, from the left side here to the right side, and now we're going to look at going from the right side to the left side. So recognizing the same kinds of patterns, but factoring instead of multiplying. Okay, so in order to help us recognize a difference of two squares, what we want to look for is that the coefficients of variable terms are perfect squares, right? Like 9 or 16 or 25. And then we want to make sure that the powers that are on our variable terms are even. As long as they are even, those variables will be perfect squares. If the powers are not even, if they're odd, then the variables are not perfect squares. Okay, so to recognize a difference of two squares, we're going to look for those perfect squares. And then also part of difference, and I've emphasized this before, is that it has to be a subtraction, right? If we have two perfect squares that are being added, then it's not a difference. That would be a sum, right? So difference means subtraction. All right, then to recognize a perfect square trinomial, what we want to look for is that the highest degree term, so whatever's in front of usually our leading coefficient, and the constant term are going to be perfect squares. So if they are perfect squares, then it might be one of those perfect squares trinomials, and then we can factor it a little bit faster. So again, these special cases, difference of squares, again, still most important one to know, but if we can recognize the other ones, it will make our jobs a little bit easier. So let's look at some examples. So we're going to look to factor x squared minus 14x plus 49. So again, always, first question we want to ask, is there a GCF greater than 1? In each of these three terms, no. X squared, negative 14x, 49, there's nothing that's in each of these three terms that we can factor out. So there's no GCF, so no. So then we look to factor. Now we want to check, okay, maybe is this a perfect square trinomial or a difference of squares? Well, it's not a difference of squares because we have this 14x in the middle. Difference of squares will always just be two terms. So it might be a perfect square trinomial. We look at the x squared term here, that is a perfect square. And we look at 49, that is also a perfect square. 49 is 7 times 7. And 14 is 7 times 2. So in order for it to be a perfect square trinomial, whatever the square root of our constant is, if the middle coefficient is double that, then it is a perfect square trinomial. So x squared minus 14x plus 49 is going to factor to x and 7 squared, and then the last piece that we want to check here is because this is a negative 14, this is going to be a negative. So x minus 7 squared. If we look back up at our pattern here, right, if we have a minus b squared, then we end up with a squared minus 2 times a times b, aka double. That's where this double the factor comes from. And then the last part is b squared. So if we can recognize that the middle coefficient is twice the perfect square root of this constant, then this will be a perfect square trinomial. So then we'd be able to factor it right away. All right, next example. P squared minus 100. Is there a GCF greater than 1? P squared, 100? No. They don't share a common factor. There's no GCF that we can factor out. First, okay, then we want to look, is it a different squares or a perfect square trinomial? Well, it's definitely not a perfect square trinomial. Keyword here being trinomial, meaning 3 terms. There's only 2 terms here, p squared and 100. P squared is p times p, and 100 is 10 times 10. So both of these are perfect squares. Again, as long as there's an even power there, it's a perfect square. So difference of squares, if we have a squared minus b squared, it always factors to a plus b times a minus b. So in this case, our a squared minus b squared, our a is p and our b is 10. So this p squared minus 100 will factor to p plus 10 times p minus 10. So there's our factors. Difference of squares. All right, factor 100x squared minus 4y squared. So again, our first checkpoint should be, is there a GCF greater than 1? Between these two terms, 100x squared and 4y squared, there is a GCF. 4 goes into both of these numbers, right? So the first thing we need to do before we do anything else is factor out a 4. That means we're going to divide it out, right? Reverse distribute, divide it out in front of our parentheses. If we divide each of these terms by 4, we'll be left with 25x squared minus y squared. So now we have 4 times 25x squared minus y squared. That 4 is just going to stay out in front of our factors. Then we look, is it a perfect square trinomial? No, it is a difference of squares, and I recognize that because 25x squared is 5x squared, right? And y squared is y times y. So we still keep the 4 out in front, and then again, this a squared minus b squared is going to factor to a plus b times a minus b. Our a and b in this problem being 5x and y. Now, if you look at the original problem, it is also a difference of squares, right? Because 104 are perfect squares. But if you factored that without taking the 4 out, then you would not have factored completely. So make sure you always look for that GCF first. Okay, so in this one we end up with 3 factors. 4, 5x plus y, and then this one should be 5x minus y. 3 factors. Okay. All right, first question, is there a GCF greater than 1 between 4, 36, and 81? The only thing that might go into all of those is 2, but 2 does not go into 81, so there is no GCF greater than 1. So then we look to factor. It is not a difference of squares, so I'm going to eliminate that right away. Then we look and we see, oh look, okay, this 4x squared, that is a perfect square. That is 2x squared, right? The 81 is also a perfect square. It's 9 times 9. 2x times 2x. So then this might be a perfect square trinomial. The 36 here would need to come from our middle terms. So I'm going to check this one because it gets a little tricky to see. But if we have 2x times 9 and 2x times 9, we end up with 18x plus 18x. And that will, in fact, give us the 36 that we wanted. So this is a perfect square trinomial. It translates to 2x plus 9 squared, a perfect square trinomial. Okay, so usually when we have that leading coefficient, we have to do quite a bit of guess and check, but when we can recognize that these are both perfect squares, it makes that guess and check a little bit easier. Okay, example 5, first thing we're going to check for is there a GCF greater than 1 between x to the 4th and negative 25y to the 6th. There is no GCF there, right? There's no x in both terms, there's no y in both terms, and there's no constant or coefficient in both terms. So then we look, is it a perfect square trinomial? No. Might it be a difference of squares? Since both of these powers are even, then this is a difference of squares. And x to the 4th is x squared times x squared, right? Or x squared squared. So that x squared is your a term. That's a. 25y to the 6th is 5y cubed squared, because when we have power of a power, we multiply these exponents, right? So 25y to the 6th is 5y cubed squared, so 5y cubed is your b. Then we have a squared minus b squared, and a squared minus b squared will always factor to a plus b times a minus b. So in this problem, our a is x squared and our b is 5y cubed. Our a is x squared, and our b is 5y cubed. So there's our fully factored problem. Difference of squares. Okay, is there a GCF in this problem greater than 1? Nope, we just have 1 and 4x squared. So this is a difference of squares. It's not a trinomial. There's only 2 terms. So again, our a here is going to be whatever we squared to get 1, and our b is whatever we squared to get our b squared, or 4x squared here. So a in this problem would be 1, and b would be 2x. Because if we square 2x, we get 4x squared. So if we're going to factor it to a plus b times a minus b, then that would be 1 plus 2x times 1 minus 2x. Here is our fully factored form. All right. And then I'm going to have you guys try to do this example on your own. Actually, scratch that. We're going to do it together. Okay. So first we look for, is there a GCF greater than 1? Between 6x squared, 21x, and 15, there is, right? 3 goes into each of them. So I'm going to factor a 3 out in front. And again, that's dividing each term by 3. So I'm going to have 2x squared plus 7x plus 5. So yes, there was. It was 3. I factored it out. So now I have 3 times 2x squared plus 7x plus 5. Okay, is it a perfect square trinomial? Is our first term a perfect square or our last term a perfect square? No. So it is not a perfect square trinomial. It is also not a difference of squares. So this is one that is not a special case. So we just have to factor it like we normally would. Guess and check. So I'm going to leave the 3 out in front. It's going to always stay in front of my factors there. I know that my first 2 terms have to be 2x and x, so then I get 2x squared there. And then I know that my last 2 terms have to be either 5 and 1 or 1 and 5, and they're both going to be positive because this and this are positive. So then it's either going to be 2x plus 1 and x plus 5, or it's going to be 2x plus 5 and x plus 1. Well, if I put my 5 here, that's going to give me 10, and that is too big because I need my middle term to be 7. So I know my 5 can't go there. It must then go here. So it's going to be 2x plus 5 and x plus 1. And then my check method, 2x plus 1 is 2x. 5 times x is 5x. And that does add up to 7x, which is what I wanted. So these are my factors here. 3, 2x plus 5, and x plus 1. All right. And then if you are watching and listening to the video, I would like you to write, well, let's do this. Cross out summary and write in key ideas. This is an Easter egg. Don't give it away. I want to see who's actually listening to the videos.